G of x means log x. G of x square means it is log x square. So this is how we combine the two functions to get the value, which is called as the composition of a function. F of minus 1 means f should be expressed in the form of modulus x. So modulus of minus 1 is 1. Any element in the set C, there exists an element in the set A. Hello everyone, a warm welcome to one and all. This is Yashruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. So we are continuing the session from the chapter Relations and Functions. So in this session, we'll study about the compositions of function. What is compositions of a function? A function of a function. So let's study the definition of compositions of function. Suppose we have a function from A to B and another function from B to C. They are the two functions. Then the composition of a function is denoted by G naught f, and it is defined from the A to C. Set A to set C is said to be the composition of f and g given by G naught f of x is equal to G f of x for all x belongs to A. Now, suppose we have set A here, set B here, and set C here. So, here f is mapped from A to B and g is mapped from B to C. Then, g naught f is a function from A to C. So this is how we define a function or a composition of a function. Now let me take an example here. We have f of x is equal to x square and g of x is equal to log x. How we define the composition of g and f? So g naught f of x is nothing but g of f of x. How a function f of x is defined? F of x is nothing but x square. So here it becomes g of x square. G of x means log x. G of x square means it is log x square. So this is how we combine the two functions to get the value, which is called as the composition of a function. Similarly, in the form of g naught f, we can also find f naught g. F naught g is nothing but f of g of x. So what is g of x? It is log x. So here it becomes f of log x. F of x is nothing but x square. So f of log x is nothing but log x whole square. So thus this is how we define a function, and always note that g naught f is not equal to f naught g. They are not commutative. So therefore clearly you can see it is log x square and this is log x whole square. They are not equal. Let me take one more example. If f of x is equal to cos x and g of x is equal to e power x. Let me find g naught f. Then this is g of f of x. What is f of x? F of x is cos x. Any function in g is written in the form of e power x. So this is e power cos x. Now let me find f naught g of x. F naught g of x is f of g of x. So what is g of x? G of x is e power x. A function in the form of f is written in the form of cos x. So therefore this becomes cos e power x. Clearly you see they are not equal. G naught f is not equal to f naught g. So g naught f and f naught g are the composition of two functions. Now let us solve few problems. Find g naught f and f naught g if f of x is equal to 8x cube and g of x is equal to x to the power 1 by 3. So g naught f of x is nothing but g of f of x. So what is f of x? It is 8x cube. How we write function g? In the form of x to the power 1 by 3. That is 8x cube to the power 1 by 3. Cube root of 8 is 2. Cube root of x cube is x. So it is 2x. Similarly, let me find f naught g of x. So which is f of g of x. So which is f. G of x is nothing but x to the power 1 by 3. How will write the function f? In the form of 8 x is nothing but here x to the power 1 by 3 whole cube. So 3 get cancels. We will get it as 8x. So this is G naught f and this is f naught g. Next one, find G naught f and f naught g. F is defined from set of R to set of R and G from set of R to set of R. That is real number. F of x is cos x and g of x is 3x square. Show that G naught f is equal to f naught g. So G naught f of x is g of f of x. G of f of x is cos x and g of x is 3x square. So g of cos x is 3 cos x square, or we can write it as cos x whole square. Next we will take f naught g of x, which is f of g of x. F of g of x is 3x square. F of x is nothing but cos x. So this can be written as cos 3x square. See, they are completely different. So therefore, G naught f is not equal to f naught g. Next one, find f naught g of minus half and G naught f of minus half. F is a function from real numbers to real number and G is a function from real number to real number. F of x is a modulus function given here and G of x is greatest integer function. So they have given, we have to show that G naught f is not equal to f naught g. First let us find out G naught f of x. So G of f of x. So the value of x is given here, it is minus half. So therefore G of f of minus half. So that means G of, what is f of minus half? It is modulus of minus half. Modulus of minus half is half. So how we'll write the function g, which is greatest integer function? Half is nothing but 0.5. So what is the value of 0.5? The nearest greatest integer less than or equal to x is 0 here. So therefore, the value of G naught f of half is 0. Now let me check it for f naught g of x, which is nothing but f of g of x. So which is f of g of minus half. That means f of greatest integer value of minus half. So greatest integer value of minus half is minus 0.5. So what is minus 0.5? That is f of minus 0.5. So this is equal to f of minus 1. And f of minus 1 means f should be expressed in the form of modulus x. So modulus of minus 1 is 1. So here we got the value G naught f of x is 0 and f naught g of x is 1. So therefore clearly they are not equal. G naught f is not equal to f naught g. So remember, modulus of minus half is half, but the greatest integer value of 0.5 near is 0. Similarly, minus 0.5 means less than minus 0.5, it is minus 1. So the nearest integer is minus 1 and modulus of minus 1 is 1. Next one, find G naught f and f naught g. Both f and g are set of real numbers to set of real number. F of x is sin x and g of x is x cube. So let's write G naught f of x. So g of f of x. What is f of x? Sin x. What is g of x? X cube. X cube means this becomes sin cube x. Or we can write sin x whole cube. Similarly, f naught g of x. F of g of x. So f of x cube. Because g of x is x cube. Then what is f of x? It is sin x. So therefore this is sin x cube. Sin cube x is different from sin x cube. So therefore G naught f is not equal to f naught g. Next question. Let f from 2, 3, 4, 5 to 3, 4, 5, 9 and g is a defined from 3, 4, 5, 9 to 7, 11, 15 be functions defined as f of 2 is 3, f of 3 is 4, f of 4 is 5, f of 5 is 5, g of 3, g of 4 is 7 and g of 5, g of 9 is 11. Find g naught f. So we have to find g naught f of, g naught f means from the set to this. So therefore here we can write it's a function from 2, 3, 4, 5 to 7, 11, 15. So let's verify now. G naught f of 2, G naught f of 3, G naught f of 4, G naught f of 5. Now, so this is G of f of 2. What is f of 2 given here? It is 3. So this becomes G of 3. What is G of 3 there? It is 7. Next we have G of f of 3. What is f of 3? It is 4. What is G of 4? It is 7. Next we have G of f of 4. So what is f of 4? It is 5. So what is G of 5? So G of 5 here it is given as 11. Next we have G of f of 5. So what is f of 5 we have? So f of 5 we have as 5. So G of 5 again it is 11. So this is the composite function of G naught f from set 2, 3, 4, 5 to 7, 11, 15. Next one. So we have a theorem. They may ask you for 2 marks question which is very simple. Show that if f from A to B and G from B to C are 1, 1, then G naught f from A to C is also 1, 1 function. To show that the given function is 1, 1 function, we have to satisfy the condition. So what we have to consider here, let G naught f of x1 is equal to G naught f of x2. Because we have to show that if the images are same, then the domain elements are same. So let's write this. G of f of x1 is equal to G of f of x2. Now given that G is a 1, 1 function. If G is 1, 1 function, G of an element and G of another element must be same. If G of f of x1 is equal to G of f of x2, then I should get f of x1 is equal to f of x2. Why? Because since G is 1, 1. Again, here also, if f of x1 is equal to f of x2, given f is also 1, 1 function, so therefore I should get their images are equal because f is 1, 1. Now, for G naught f of x1 is equal to G naught f of x2, we are getting x1 is equal to x2. So, therefore, I can conclude G naught f is 1, 1. Next, show that f is A to B and G is B to C are onto, then G naught f from A to C is also an onto function. What is the condition for onto? For any element in the codomain, there must exist an element in the domain such that f of x is equal to y. So, given f is a function from A to B, so let y belongs to B such that f of x is equal to y for all x belongs to A. Similarly, we have let z belongs to, this is B here, z belongs to C such that g of y is equal to z for all y belongs to B. Because they have given f is an onto function and g is an onto function. So, for every element in B, there exists an element in x, and for every element in C, there exists an element in B. So, now consider G naught f of x. So, G naught f of x means G of f of x. What is f of x? F of x is equal to y. What is g of y? G of is equal to z. So, this means what? So therefore, for all Z belongs to C, there exists what? An element X in A, in set A, such that G naught f of x is equal to Z. This is satisfying the condition of onto. So for any element in the set C, there exists an element in the set A. That means what? G naught f is from set A to set C. For any element in set C, we have an pre-image in set A. So therefore, what I can conclude, G naught f is onto. Hence it is proved. Next one. So here it's a composition of function in the form of an associative. If f is a function from x to y, g is a function from y to z, and h is a function from z to s or the function, then show that h naught g naught f of is equal to h naught g naught f. So let me take h naught g naught f. So this can be written as h naught g of f of x. So let me take an element x here, and this can be written as h of g of f of x. Now here let me take h naught g naught f in the form of x. Then I can write this as h naught g of f of x. Again I can write this as h of g of f of x, which is one and the same here. So therefore I can write h naught g naught f is equal to h naught g naught f. Hence it is proved. So that is what we can say, the composition of a function is associative. Remember, the composition of a function is not commutative, but the composition of a function is associative. Next one, let f is a function from n to n, g is a function from n to n, and h is a function from n to r, that is real numbers, defined by f of x is equal to 2x and g of y is equal to 3y plus 4 and h of z is equal to sin z. Show that h naught g naught f is equal to h naught g naught f. That is, we have to show that these two are same. Let's find out h naught g naught f, which is nothing but h of g of f of x. So here, let me write h g. What is f of x? F of x is 2x. What is g of y? G of y must be written in the form of 3y plus 4. That means here I have to write this is in the form of y is in the place of 2x. I have 3 into 2x plus 4. So that means h of 6x plus 4. So sin z, we have h of z in the form of sin z. So whatever the function is z here, it should be written in the form of sin z. So therefore it is sin 6x plus 4. So now this is again sin 6x plus 4. Now let me take h naught g naught f of x. So here we have h naught g of 2x, because f of x is equal to 2x. Next, we can write this as h of g of 2x. So what is g of y? G of y should be written in the form of 3y plus 4. That means I can write this as 3y means 2x plus 4. Again, this is h of 6x plus 4. How is the function h written? H of z in the form of sin z. So therefore this is again sin 6x plus 4. See here we have h naught g naught f is also sin 6x plus 4 and h naught g naught f is also sin x plus 4. So therefore I can write h naught g naught f is equal to h naught g naught f. Hence prove. So this is all about the compositions of a function. So I hope you understood how to write a composition form of a function in the form of g naught f as well as f naught g. We'll meet you in the next session with a new concept in the chapter relations and function. Until then, keep watching, keep learning, keep exploring. Thank you.